All right. It looks like it's about 9:30, 9:31, something like that. We have a couple of people on the stream. Oh, I'd ask a chat question. Let's see what. Oh, so we've got 50%. I think there's like 1 and 1. It doesn't say. Oh yeah, 2 votes. So there's 1 and 1. So, but the question was, have you successfully printed anything yet? One person has. One person. Oh wait, now 2 people haven't. So, oh no, we're back to 50-50. It's going back and forth. So, so the point isn't necessarily that you have successfully 3D printed anything yet or not. The whole course goes, 10 weeks more or less, and we will, over the course of that, actually you can complete the course without a printer at all. So you can get through the whole content without printing anything. I think it's better if you do at least have access to something to print with. Maybe it's not your own printer, but you can send files somewhere and get them printed, or you can have maybe a library that has a printer that you can use, something like that. I think it's going to be best if you actually have your own printer, but you can get around the whole course without printing anything, so it's totally fine. Now we're up to 50-50, so 4 people voted. That's good. These streams, you can watch them later, and obviously you won't be able to vote if you're watching when it's not live, I don't think. I'll leave it up there for a little while in case somebody else pops in. But what my plan is, so let's see, let's go over here. Let's go here. So this is our page that contains all of the content. So one way to take the class would be to just go through the whole thing at your own pace, and there are already videos on all of these. Like if you click the class link, there will already be a video there from a previous year. There's actually 2 on this particular one I clicked on. They may or may not relate to that topic that I've got listed there, because the 3D printing world changes pretty rapidly, and so, or at least currently it's changing pretty rapidly. So there are things that pop up that I want to talk about, and so I insert them where the previous year or the previous quarter I taught this, we did a different thing. There are some things that are pretty standard that we will talk about each time. This day in particular, we're going to talk about some tuning. Now I do have one problem with that, and that problem is my printer still in a box. So we'll open it up, and we won't assemble it today, at least not on the live stream, but we will open it up. So I won't be able to actually show like the printer receiving any of these commands or calibrations, but I am going to talk about them. Let's go back over here. So the course is set up to where you can do your own pace. If you want to join the live streams, that's great, and actually I like that more. Feel free to put things in the chat, like ask questions if you want a particular thing, more detail or whatever. The chat is delayed a little bit, 10 seconds or something, so and I may not see the chat immediately, but feel free to interact there. We do have the Discord channel where you can interact there, and you can interact on Canvas. What you actually do for the assignments, there's a link here for turn in assignments here, and so there are all sorts of I think they're set up as forums, so you can post a thing and then talk about what you did. I assume no one's actually posted anything yet, although it does look like somebody has, because I've got 2 things to grade over here. So maybe some people have already posted some calibration prints and a Benchy. Most of these, the optional ones, or what take up most of the stuff you turn in, there's a whole set of things that you could turn in. If you're not sure what those are, if you go to the General tab, I believe it's in the syllabus is where I put them. Let's make sure about that. Yes, so they start, well, these that are labeled something are particular things, but then there are options. All of these are things that you might want to do your version of, and they're pretty broad, toys, games, and yo-yos. So you found a toy. Oh, you found this guy. You wanted to print this guy, so we'll put him over here so he's laying down. You want to print Starscream, so you print him out, and he probably actually fits into a couple of these categories. For instance, he's got movable joints. He's a multi-piece model for sure. He's got lots of pieces there. He's not painted. Those are all different colors of filament, snapped or glued together. I don't remember which I did. It looks like I snapped because they move. So he's articulated, and he's a multi-piece model, and he's a toy. So he would go into a couple of these categories. He would certainly go in this category. And so what you would do is you would take some pictures of the thing that you printed, Starscream, and then you would post in the option, you want to use him as option 1, let's say, is the first thing you do. Although, I don't know if he'd be the first thing you do or not, but he's the first thing you did. And so you go to turn in assignments here, you go to option 1, and then you turn in, you create a thread of your own. So each student will have their own thread in each of these categories. And you create your own thread, you can name it Starscream, you put some of your settings, you put where he came from, unless you made him yourself, like the STL file. So he, in particular, came from this site, toymaker3d.com. I put a link in the in Canvas. So there's a lot of free ones too. So maybe you don't want to pay any money for these. So there's a bunch of free ones. I don't think he is a free one, Starscream, but there are other. There's Bumblebee, there's Hound, and a couple of others that are free. And so you print him out. So, and then you upload a couple of your print settings. I printed him on a Ender 3 0.2 millimeter layer, whatever all the settings are. And then at some point it will get graded. It is not, the optional assignments, actually all of the assignments are not due until the very end. I do that on purpose because it does let you overcome difficulties. So there's a good chance that something throughout the quarter, the 10 weeks, is going to go wrong with your printer, and you've got to fix it. So it gets jammed, or it gets clogged somewhere, or something actually breaks on it. Although that's not not as common. Usually it's something gets clogged or jammed, or you run out of filament. Something, you got to go get more filament. And so I don't really like having a specific deadline for everything, because for one, y'all are all over the place. Some of you are here, some of you could be anywhere in the world taking this class, and so it's difficult when I can't actually go and help get your printer back running. So I just have everything at the end is the final due date, so sometime in August. I wouldn't wait until the end to put everything up, but that is the final due date. All right, what else is there about that sort of thing? So hopefully you do have access to a printer, or you do have your own printer. If you don't, then I don't think I've pulled them out yet, but I do have a set of assignments that are don't require printing. So maybe they're a discussion on flow rate, or whatever it is, something that where you don't actually have to print anything, or you comment on how a particular calibration works, how do things work in the printer. And so if you don't have a printer, then you'll do some alternate assignments that don't require you to actually print out anything. All right, so my goal for today is to talk about this idea of tuning. Now, what printer I have, again, still in the box, Starscream guarding it, I have an Ender 3 in this box, in pieces. So it's just a plain Ender 3, nothing, it's not even the V2, it's not anything special. It is the base level Ender 3. You can usually get these for like $99 if you find them on sale. So it's at the lowest of low end. Oh, and it's actually not the lowest of low end. I saw one for like $62 from, I guess it was from Temu or something like that. It's all plastic and it doesn't look very good. This is probably what I would say is the lowest of the low end, where you can still get decent prints out of it. So throughout the quarter, I'm going to build this, and then I've got all sorts of upgrades that we'll explore. You do not have to do any of the upgrades. Probably your printer actually has most of this stuff already built into it, and so you don't even need to upgrade your printer. But I'm going to show you what some of the upgrades are, what some of the different things that you might consider for your next printer, or maybe your printer has this. this feature and you want to know more about it. So most of the course is going to be focused on FDM, so fused deposition modeling or method, depending on who's interpreting that. But it's the idea that you take filament, which I should have had a roll of filament out. I don't see one right now, but a roll of filament, so just plastic, a thermoplastic, so it is one that you can heat up, it will soften, and then when it cools down, it'll hold that new shape, and you can do that several times. Eventually it stops working well, you know, it doesn't heat and hold its new shape very well after several iterations of that, but ideally we print it once and it's done. So you take this thermoplastic and you heat it up and extrude it like a hot glue gun, except the nozzle is much smaller than a hot glue gun and the filament is pretty much smaller than the hot glue stick. But you do that, you use the machine, the printer, to control where it deposits this filament, and you build up objects one layer at a time. There are other types of printing that we'll talk about. Actually, one other one that we'll look at in the stream, but most of the other types are not something that I can have right here. They're way too expensive, you know, $500,000 kind of things, and I'm not going to have one sitting right here beside me. So we'll talk mostly about FDM, but we will talk about resin printers. You can get really affordable resin printers where you, instead of a solid filament piece of plastic that you're melting, you take a liquid polymer and you shine a particular wavelength of light on it and it hardens, and so you could selectively cure that liquid resin into a object. The advantages there are that you can generally get much higher detail. So if you're trying to print something that has lots of tiny fine details, then that's maybe a better process than the FDM. There are other processes where you shine a laser beam on a powder and selectively melt that powder into the object you want. Those are a little bit more expensive. There are some of those machines that are at least approachable, but they're still maybe $15,000 for the lowest end of that kind of printer. And they go up way higher than that. And then there's a selective laser with the polymer also, so that it's kind of like the one that I've mentioned earlier, but it's a little bit different. It's laser based instead of UV based. So we'll mainly focus on FDM, which is what I have in this box over here. I switched the screen back to here just because you were just staring at a box, so that didn't seem very exciting. So why don't we open up our box so you can kind of see, if you haven't gotten your printer at all yet, you can see kind of what's going to be the major pieces. All of the printers are going to have some of these pieces similar. This one is, like I said, the Ender 3, and it's one of the, not the oldest kind of these printers, but one of the more popular cheap ones. And they have been around a while. And they have a whole line of printers from, this is Creality Ender 3. They have a whole line of printers, with this being their bottom end, sort of. They do have a smaller printer, but it's actually a little bit nicer than this one. So most of these printers are going to come mostly assembled. Actually, a lot of them will come even more assembled than this one. This one probably takes 30 minutes to an hour to assemble, depending on how familiar you are with assembling it. So that's why I don't want to do it on the live stream, just because it would take up most of the time. But we'll get it out of here. So here, let's see if we can arrange a little better. There we go. There's all of it. So this surface right here is your print surface, and so you can kind of see roughly the size, 225 millimeters square, something like that. If I saw a ruler around here, I would measure it, but I don't see one right now. So somewhere in that range for the print area, and the volume is similar. I think the volume on this, the height is 300 millimeters, somewhere in that range. You probably can't get all of that. You can't print right on the edge, you can't print right at the top, but you can print some really large pieces on this. In general, for your first printer, I don't know that you need a very big printer, because most of the stuff that I end up printing, you know, they're like this guy. So there's Starscream. He is not, you know, all of his pieces together would fit on here for one thing at one time, although they're different colors, so that's another issue. But you know, you can print some relatively large stuff on a regular size printer. So this is a good one to start with, particularly if you can get it for $99 on sale. Which, if you look around, you usually can find the Ender 3 base models in that price range. So this surface is where your part will end up printing. And let's get some more pieces out of it. Well, let's see what's in this bag. So I've got a bag over here. So this is going to be the little control panel. So again, this is the lowest of the low end for the Ender 3. And it's just, you interact with a dial here, and you can click it to select things. So you've got a little screen here. It's not a touch screen on this printer. Some printers do have touch screens. Some printers you can interact with your PC or your iPad or your phone even. We'll actually set that up on this printer, but it's an add-on. It's not something that comes with the printer. So that's how we're going to interact. And you've got a little circuit board. This is not the brains of the computer. This is just for the circuit, the display here. So I've got that piece. Let's see. This is an important piece, or pieces. So let's look at this part up front. So over here, let's see if we can get a little closer. So over here, you've got this brass wheel, and it's attached to what's called a stepper motor. This is what's going to feed the filament into your printer. So the filament's going to come in, actually, let's see, right here. It's going to come in here. Going to be driven by this brass wheel that's attached to this motor. And it's going to come out here and head off towards your printer. So the rate that we feed filament in does matter. So we can't feed it in too fast or too slow. That's one of the calibrations that we'll talk about today, is getting that thing set up to where it feeds exactly the right amount of filament that I'm expecting to go into the print. So we'll look at that later today. Most of these printers, you build them and they're pretty good straight out of the box. I am going to show you a bunch of tunings and calibrations that you may not even need to do. But they are, for one, they let you understand kind of how the printer is working, like the concepts behind how it's working. And so they're useful for that. And it is possible that you change something. We're going to change this some point in the quarter. We're going to change this little feeder, and we'll need to recalibrate when we change that. So it's possible that you upgrade or have to replace something, and you end up needing to change out a part, and then you need to know how to set it up to calibrate it. So we'll talk about that. This other motor, this is the similar motor over here. This one is driving one of our axes. So this particular printer is a Cartesian coordinate system, so X, Y, and Z. So there are 3 motors, one for X to move it in the X direction, one for moving in the Y direction, and one for moving in the Z direction, and then this 4th motor here that is feeding filament. So total there are 4, but for the movement system there are 3 on this printer. Some have more, but this printer only has 3. What else is in here? A lot of these printers are built on extruded aluminum 2020 pieces, so they're 20 millimeters wide and 20 millimeters tall. This is actually 2 pieces for building the printer. Again, this one is less assembled than a lot of your printers. Some of the printers that you get these days are 2 or 4 screws and it's totally done. This one does have a little bit more. When I first started teaching this class, it was literally a box of stuff like this. None of this stuff where it's all pre-assembled. It was just a box of parts like this, and you had to assemble it from, you know, raw parts. So you didn't have to cut them to length. Actually, the very first printer I did, you did have to cut it to length. But it was, things have moved along nicely with the opening of competitors and other vendors in these markets. And so you get a little bit easier process on assembling things. You do have to be careful because they are assembled, and again, for this one in particular, it's assembled, and the whole point of it is this going to be the lowest cost that's decent. So you can run into some assembly errors. Maybe things aren't quite square. Maybe a screw is still loose or something like that. So you do have to check things when you're assembling, particularly the lower end printers. But that's kind of what you get. Let's see what else is in here. Let's see if we can get this piece out. This is the largest piece that's assembled anyway. And it's in this box down here with the little vent on it. That's where your brain is. And here's a couple of ways to interact with it. You have a USB and a SD card. I do like using SD cards, but this particular SD card is so tiny and it's down at the bottom. It's kind of hard to deal with, but you'll get used to it, I suppose. But this is the bed where it moves. It moves forwards and backwards. And there's its motor back. Oh, it's off the screen. Back there, the motor that's controlling it. You'll notice that there are several switches. So here's a little switch back here. Let's see if I can, yeah, right there. Little clicky switch. That's how the machine knows where it is. So those are limit switches, and there's one for each axis. And the first thing your printer is going to do before it starts printing anything is it's going to go and drive all of your axes to their home position so that it kind of knows where it's at. Other than that home switch there and the ones for X and Z, it doesn't know anything. It only assumes that it's doing the right stuff. It has some coding that will generate, and that code gets loaded onto the SD card, into the brain of the printer, and things start happening. And it just assumes that the right things are happening. So most all of the printers these days are pretty dumb. They only know this. That's the only feedback they get. And there are some that have a little bit more intelligence. They've got some feedback on if they have filament or not. But beyond that, there's not a lot built into these printers. It's evolving. In fact, some of the research projects I have at school with some of the grad students are to try and build a little bit more intelligence into these printers so that they know if stuff is going wrong. They can kind of evaluate if they're kind of falling apart, and maybe they're shaking too much, and it's an indication that something's not quite right. And so we're trying to add a little bit more intelligence to them, but most of your printers, even the more expensive printers, this is all they know. They have a couple of switches. Maybe they're not clicky switches. Maybe they're infrared gates, or maybe they're some other kind of sensor that is basically telling the same thing. But that's all they know. Some of them know if they have filament or not, and that's about it. So we're going to get this piece out. This is arguably the most important piece. It's actually connected to it. This is your extruder. So inside here, under this cover, is the actual part the filament comes out of when it's extruding onto your part that you're trying to make. That little, well, we can take this off. That little brass piece right there, that's the nozzle the filament comes out of. So when you're printing, you don't want to be around this. This is 200 degrees Celsius when you're printing, or more. So this gets really hot. That's why it's got a fan on it here to try and cool it down so that it doesn't melt your filament way up somewhere else and get jammed. It has another fan or two on the side to cool the filament once it comes out of the nozzle and it's part of your print. You need to cool it down for most filaments. And so we'll take this apart later on. We'll actually replace this. I think I bought some replacement parts for this one. Why are we not fitting here? It only goes on one way. I got to get the right direction. I think that's it. So that's just a little silicone sock that kind of keeps the heat from this away from other things and helps control the heat. One of the calibrations we'll look at today is about calibrating the heat that's built up in this nozzle. Obviously, if you can't control the heat then your filament's getting too hot, it's getting too cold, it's too gooey, it's not gooey enough, and so you need to be able to control the heat here. Oh, I was wrong. I totally forgot. There are other pieces of information it knows. It knows, let's see, I can't see the wires for it, but they're in here. It knows the temperature of this block and the temperature of this bed. So there are two other pieces of information that it's not it does know a couple more things. So it knows a couple of temperatures. It knows how hot this block is, and it knows how hot this bed is. And those are actually maybe the most important things. Well, I guess the homing switch is, it needs to know where it is too. So all of those are kind of the minimum set of things it needs to know in order to actually print something. And so controlling the temperature of this heat block is going to be really important for having a nice print when we're done. So let's get this assembly out. I don't know that there's much more in here that's going to be interesting to look at, but there is a power supply. So having trouble getting it out. There it is. All right, so this is a larger power supply, but these are just PC power supplies. I already see a problem. Not a problem, but a thing you have to check. So if you're building one of these power supplies can run, almost all of them can run off of 110, I think it says 115, or 220 volts. And they're selectable with the switch kind of on the side here usually. And this one, I don't know if you can see it because it's kind of blurry and tiny, but it says 230. So this is not going to work correctly until I switch this over to the other side. So 115. So check that before, if you're assembling a kit printer, so kind of like these where you've got different pieces you've got to bolt together, check that switch is set over to 115 or 110, whichever. Those are essentially the same thing. It's just voltage, but it's usually, if you're in the United States anyway, these need to be set to the 115, 110 version, not the 230 version. All right, so we've switched that over. Now we'll be able to plug it in to the rest of the printer and it will power it correctly. Let's see, there's usually some more stuff under here. So I've got pieces of a filament holder. The filament comes on a spool, so it comes in a round. Let me get one so that we can make sure we're talking about the same thing. Okay, so here is a spool of partial spool of green PLA. So, oops, we're upside down, huh? PLA, so green PLA. So this is kind of the raw filament. You know, it's just a little string of filament of plastic. Now, there are two sizes of this. Most everything these days is 1.75 millimeters. Pretty much that's what everything is, but there are some a few printers, not many, but there are a few printers that use a 2.85 millimeter or 3 millimeter filament, so it's quite a bit larger. So when you're buying filament, you go to Amazon or whatever and you're not seeing it in person, make sure that what you're getting is the 1.75. That's probably what your printer's using. If your printer is using something else, you probably already know it, because you specifically bought a printer that used larger filament. It's larger. There are larger ones, and that was way more popular originally, like 15 years ago, maybe somewhere in that range. They didn't have spools of filament that you could just go to Amazon and buy. So people used weed eater line, and it's closer to the 2.85 millimeter. And so that's why it does have some advantages, but most printers nowadays use the smaller 1.75. There are different types of filament. So I pointed out that this one is PLA. That I would recommend, again, if you are brand new to printing and you don't really have a reason to do anything other than you want to start printing, I would recommend starting with PLA as your first selection of filament. I assume somewhere in here There, yeah. Look, this is what you get to start with. There's at least in this printer. And again, this one is the lowest of the printers you can get generally. So you get that much, just enough to make sure the printer turns on and spits out a part. But that's what you get, is a tiny amount. It used to be that you got entire rolls. Like this is an entire kilogram of filament. Just so you know, assuming you don't care about switching materials or colors, one roll like this would last the whole quarter for the assignments anyway. Now you might want to print more on your own, but one roll would be plenty for finishing out all the assignments. You'd have you know, this much left over probably. But I would recommend PLA to start with. This is Matter Hackers. They're a good brand. There's several good brands now that are not going to give you problems. It used to be that there were some brands that were tangled up. You know, you would get them and the filament on the spool would be all tangled up. It's not easy to use. It would be different diameters. You know, it would go thin and thick and it would jam up your printer. But pretty much everything that you get off of the internet, or if you have a place you can go and actually buy the stuff, then pretty much all of it nowadays is decent enough for printing. It should cost about $20 a kilogram. You can certainly find it cheaper. You can definitely find it more expensive because there are lots of things that you can add in to this filament to make it do different stuff. It can be flexible. It can be glow in the dark. It can be made out of wood. It can be all these different stuff can be added into the filament to give it different properties. Carbon fiber. I would not start with any of those, mainly because most of those additives, this little nozzle right here, oops, barely on the screen, it's made of brass, and most of those additives will wear this brass nozzle away pretty quickly, and you'll end up needing to replace this nozzle maybe before you're ready to. So we will do a nozzle replace and a swap throughout the quarter, and you can change them to harder materials if you want to, so that they don't wear as easily, but they don't conduct heat as easily when they're steel versus brass. So I would just start with a plain PLA. Pick some color you like, but don't get the glow in the dark or the wood feel or any of the stuff that makes it a little more complicated. If you haven't done this before, just get a plain PLA that you like the color of. About $20 a kilogram should be about right. There's our filament holder. Got a couple more pieces. You usually get a bag of parts and tools, although I'm not seeing any. Oh yeah, there's a couple of tools in here. Little scraper. Oh, let me point this out. They usually do come with a SD card. So there's a little SD card in here. There's almost a 100% chance that this is an unbranded SD card. Whoops. Let's see. Yeah, there's not anything at all on there. So I'm going to say that will work for some amount of time, but I would replace the unbranded, you know, cheapo, technically it works SD card that comes with your printer with something, you know, something that you know is more, a little more quality. Doesn't have to be super high end or fancy, just something that's not a unbranded, wherever this thing came from, SD card. Because what's going to happen with a lot of these is that this one's even worse because it doesn't say anything on it, but it's going to say that it's a 8 gigabyte card, and you put it in your computer and it shows up as an 8 gigabyte card, but it's been formatted in a way that it probably is whatever they had available that was cheap. You know, it could be a 256 megabyte card. Who knows? But your computer's going to think it's an 8 megabyte because it's been tricked into thinking it's an 8 megabyte. And you're going to load a file on there, and only a piece of the file is going to get onto the SD card, and your printer's going to print, and then it's just going to stop because the rest of the file is not there. It thinks it loaded it there, but it's not there. So Plus the quality on these, you know, they're likely to fail. It's just not worth it to put any long print. You know, you're trying to do your first benchy and it's going to take an hour. It's not worth it to do a long print on one of these unbranded SD cards. It's just too risky unless you have no other option. They will work, but you don't really know if you're going to use these. So what I would do is, if you're going to use these, only ever have one file at a time on it, so that you have, because you have the most chance of it succeeding. I'll print one off of here, I guess, just to show that it can work, but I've had too many issues with these unbranded SD cards. So got some other parts in there that are going to need to assemble it. A couple of other stepper motors. This is the one that drives the Z-axis up and down, and I think that's what we've got in our little box of parts. Again, I'm not going to build it on the stream. I actually think if you go back a couple of years, I do have a live build of basically this same printer. If you're wanting to see some of the you know, where the parts go, somewhere in here there should be some instructions. Maybe I don't see those. Oh, I think they're over. I think I took them out. They were the first thing on top, and they're just sitting over there. But if you want to see a build that goes from start to finish, I think I do have one that's a couple of years old, and it's the same printer. It's just they haven't changed this printer in a while. Oh, we got one more vote, so a sort of vote. So yeah, there's a lot of your first prints are going to be, yeah, I kind of printed it, it finished, or maybe it mostly finished, and we're going to get it to where your prints come out nice. But there will be some sort of prints for sure. All right, let's go over to our web page. We've got a few minutes. Actually, we've got quite a few minutes, I think. So let's talk about, if you were to look in here in the class 3 deal, I've got well, there's some of the previous videos, some little short ones too. I've got a description here of these two calibration ideas. So one of these, the one with this diagram, this is PID tuning. So this is a control system that your printer will use for the nozzle. Some printers will use it for the bed also, and I'm not sure on this printer which it uses for the bed. We'll have to actually look in its firmware to see what it's doing, but I'm not actually sure. But what PID is you could think of one way of controlling something, like if you have a temperature, you want it to be at 200 degrees Celsius, and then you could think of one way I could get my heat block up to that point is I could measure its temperature, and if it's below 200 degrees Celsius, I could turn the heater on, and if it's above 200 degrees Celsius, I could turn the heater off. Maybe I could get more sophisticated and say that, well, I know that if I turn it off at like 195, then it will be close enough. And if I let it go all the way to 205, it won't get it too hot. And so maybe those are my on and off switches. That's one way to control it. That's called bang bang, where it's just on and off. And you have some threshold or thresholds that control when it's on and off. That's bang bang tuning. That is okay if you just need like a coarse kind of tuning, but if you want something where you're really trying to keep this temperature constant, think about what's going on. You know, you've got your filament is coming from ambient down into the hot end, getting heated up. So you're having to dump heat into that filament that just came from ambient temperature, which is, you know, room temperature, 20 something degrees Celsius, and you want to get it to 200 degrees Celsius. So there's a delta, a change or a difference between the filament as it comes in and the filament as it goes out. There's a pretty big difference in temperature, and so you're having to constantly dump heat into there. Your printer's out in the open usually. These aren't enclosed. You can enclose them, but most of your printers are not going to be enclosed. So they've got ambient air surrounding them. They've got fans blowing on them, cooling them off and cooling off the print. And so there's this constant battle of trying to get enough heat into the heat block to melt the filament right. But if you put too much heat, then it just turns into a gooey mess and it can't extrude. So the bang bang process is not ideal for that. So that's where the PID process comes in. So this is just a generic PID diagram, not one specific to your printer. In fact, it just says control device. That would be the printer, well, the hot end of the printer. And there are 3 parts to it. So instead of just having a threshold that you're trying to go above or stay below, there's proportional, that's the P, there's integral, that's the I, and there's derivative control, which is the D. And so it's taking a look at 3 different things. So proportional is, hey, I am at 50 degrees Celsius, I want to get to 200 degrees Celsius. That's a big gap. I'm going to dump a lot of heat. So it's just proportional to how far away you are. So in fact, you can, if these equations look familiar to you, then you can just see it's some constant multiplied by my function. So it's just, I'm just multiplying it based on how far away I am. That's good, but we need a little bit more. So the I part, you can kind of see integral. So if you know some calculus, then you see that integral symbol. You know that what I'm doing when I take an integral is I'm accumulating information. I'm measuring the area under a curve. And so this is saying that I'm looking back in time, basically, over some amount of time. I am trying to accumulate what has been happening previously. And so I've got this proportional thing. Hey, I'm really far away. Here's what's been happening. And then the derivative, the D, is the rate at things are currently happening. So it's kind of trying to look at the past, look how far away I am, see currently how things are changing, take all 3 of those factors, add them together, and control my device in some particular way that gives it a lot finer tuning, so that I don't have a lot of overshoot or undershoot. I'm not constantly bouncing back and forth between a high and low state. I'm just trying to ramp up to some, in this case, like 200 degrees Celsius, and really just stay there. But I have to be able to look at what's happened in the past to kind of see, what's been happening, what's currently happening with the current rate, so I can make predictions about the future, and then the proportion of how far away I am from my set point. And the combination of those gives me much better control. So that's how your nozzle operates. So the problem with that is that these KP, KI, and KD, those numbers matter. And the numbers on this printer that I got here, you can't see the label, but it came from China. And so, the conditions in China are probably not the same as the conditions they are right here. So they may not have been printing a different filament when they tested this out, or maybe they just take some generic numbers that kind of work for all printers and plug those in. But if I want a very particular thing, I've got my printer set up. I don't know if you can hear it, but there's a fan over there blowing air across here. So I've got this constant air that I've got to deal with. Or maybe I've enclosed it in an enclosure and it's going to heat up that enclosure, and so that's different. So anytime I have a different set of environmental factors, even a different filaments and different colors of filament conduct heat differently. So once I've got things set up the way I want them, then I probably should go and do a PID tuning on my printer. And that's what these steps are here. I think I've got, 6 steps for, 6 is just, doing it again. But so for like 5 steps to tune the PID values for your particular setup. The general idea is you can, either a lot of printers can do this on the printer itself. So on this little guy, your control panel, there's probably an option in there for PID tune. And so you can just click the button and it does it and you're done. If it doesn't have that, maybe your printer doesn't have that enabled, or you want more control, then you can log into your printer using, I usually use a program called Pronterface. You can see it highlighted there. print run pure Python 3D printing host software. So Pronterface.com right here. You can probably download it. Looks like the last one was 2014, hadn't been updated in quite a while, but it does what it needs to do. Because I don't use it for much other than directly talking to the printer. But you can print from there too. I really only use it for talking directly to the printer. So that's what I've got. There's our guys again. That's where I've got these commands set up in Canvas here. If you don't have the availability to just PID tune on the printer itself, these will do the PID tuning. You'll see a lot of these like M503. I'm gonna make them a little larger, like M503 or M303E. All these little pieces, these are actual code. So your printer, more than likely, unless you have a particular brand of printer, but most printers out there operate using G-code, and a lot of those G-code running printers are using a firmware that's called or based on Marlin. And these pieces of code are things that you can send. They're commands that mean particular things to your printer. So like this M303, that is a PID auto tune command for most printers, well, at least the ones running Marlin, which are most of them. E0 means extruder 0. That's your nozzle. You know, a lot of when you're dealing with computers and electronics, a lot of the first ones, you know, the first nozzle or whatever is actually indexed at 0. So E0 is the nozzle. Set point of 200. So I'm gonna I want to tune it to print at 200 degrees. I am mostly going to print PLA at 200 degrees Celsius. So I'm going to tune my printer for that. So maybe you're printing ABS all the time and you want to tune this to 240, whatever it is. C8, so that's how many times do I want it to run through the tuning routine. So that's 8 times, a count of 8. Or 8 cycles, I guess would maybe be a little more accurate. Then you let it do its thing, and you will get a list of new values for KP, KI, and KD. You'll type those values in. Here's M301. There's the value for P. These are not values that mean anything. They're just, I don't know. They're probably the values I had from one of these Ender 3s at some point in the past. But so there'll be numbers like this. P22.2. That is the coefficient that goes right here in this control scheme. And then you'll have one for I and one for D. And then this command will store them in your printer temporarily. You have to permanently store them with this command M500. Once I build the printer, we'll go through and we'll actually tune this printer PID tune. I'm just giving you an overview of what it does. You can actually follow this guideline if you want to, and it'll walk you through using Pronterface to PID tune any printer that at least runs G-code and Marlin. There are some printers that don't, so be aware that there are some printers that use proprietary control systems that don't use Marlin, or they don't use the Marlin version of G-code, so they use a different system. So this may not work on every printer out there, but it's going to work on most of the printers. And then you can save it and do a test print. There's a good chance that unless you change something dramatic, like maybe we changed our nozzle here from brass to hardened steel, that would be a pretty dramatic change. Or we changed the heater. Well, where's the heater? There's the heater wire right there. Can't get it in the screen. There it is, down in there. Maybe we changed some of the actual hardware, then it would probably make a big change. But if all you did is move the printer from one side of the room to the other, unless there's a drastic difference in that area, then it's probably not going to make a huge difference in your prints. But if you just are trying to get everything as good as it can be, then this is an easy thing most of the time, particularly if you can just use the control panel and do it on the control panel. Then it's an easy deal to adjust. A little bit more complicated is the eSTEPS. Where did I put E? Here we go. So that is, where did he go? That's this one. And we need to be able to make sure that this stepper motor is feeding out the right amount of filament for the print. Because again, our printer doesn't know how much filament's coming into it. It just knows how much is supposed to be coming into it. And so if this is tuned badly, or you've changed something, maybe you changed this mechanism. We're going to change, this is all plastic, kind of glass reinforced plastic stuff. We're going to put metal up here, and so we're going to change out parts. Maybe we've done that, then there's a good chance we need to modify our eSTEPS. So E in this eSTEPS is extruder. So I usually call this guy the feeder. A lot of people call this one the extruder. I usually call, you know, oh there it is, kind of back in the back there. I call this guy the extruder because it's the part where the filament actually comes out, and all of this does is feed filament into that one. So I usually call this the feeder, but a lot of people just say extruder. And so eSTEPS is, and sometimes, actually, go ahead and point this out. Sometimes this is bolted directly to that other part, and so they're kind of the same piece. All right, anyway, the extruder steps. There are a little bit more difficult to tune, but the general idea is that, again, you may be able to control them from this menu, and I think on the Ender 3 you can, and on a lot of printers you can control them from here. But the general idea is that I'm going to ask for 50 millimeters of filament to be extruded or fed through the feeder. I'm going to let it run, see, and actually measure. I'm not going to print, so I'm not going to send that filament over to the print head, but I'm going to just send the filament basically out here. So in here, 50 millimeters out there, and I'm going to cut this piece off and measure it. And if it's 50 millimeters, then the eSTEPS are set correctly. If it's 100 millimeters, then my eSTEPS are way off. If it's 10 millimeters, they're way off. And I can adjust. In fact, I've got a little equation right here that kind of helps you adjust the eSTEPS. So updating the eSTEPS, you may be able to update them through this here, or again, I have the version, or the list here is going through Pronterface again and typing code directly into the printer. If you just want to deal with these, that's totally fine. I just do like showing you that you can get low-level control of the printer directly if you need to. And it is good to, at some point learn a little bit of these commands, because you might want to do some very specific things, and you need to write it yourself sometimes. But don't worry that you think you have to do that, though, because that's very, very specific cases. In general, you're totally fine just slicing apart and using whatever comes out of the slicer. All right, so we're getting close on time, but we got a little bit more. I do want to show you, just to make sure that we're all on the same page as far as slicing and that sort of thing before we get too far into like updating eSTEPS. I would not worry too much about the PID and eSTEPS until I've gotten some level of prints done. I'm able to slice a file, send it to the printer, and get something to come out, even if it is the sort of came out kind of thing. Let's look at let's look at a slicer. So I've got Cura over here. Let's see. Oh, wait. I've got Cura over. Hold on. I've got to add some sound on the, so it'll be silent for a second. All right, I think, yeah. All right, now I think we have sound, and we have, oh, we have something that we can see our chat. So actually, let's just make this. No, I don't want to cover up the whole screen. So there we go. So this is Cura, Ultimaker Cura. You can kind of, it's tiny, but you can see it up there. Oh, well, actually, it's larger right there. You can look at it right there. This is one of the ways that you could go in and slice a file so that you can print it. There are many of them. Cura is free, so that's one of the reasons I use it. And it has a lot of printers already built into it. So probably whatever printer you have, probably they have a profile already set up. We'll actually set up our printer once I assemble it. We'll set it up. That'll probably be Wednesday's stream, is actually going through and getting our printer set up and doing some prints on it. Maybe even running through the PID and eSTEPS live. But the general idea with these printers is that you have a view of the bed. So this is for an ender. It's not the one that we have. This is another one over there that does a little bit different thing. But kind of like the volume, what you can print, you know, kind of gives you an outline of what you can print. So the idea is that you find a file that you want to print. Either you've created this file, you scanned in something and you're going to print something you scanned, or you just downloaded it. So let's just say that we want to go over here and we want to print Bumblebee. So he's free. We'll download him. We're going to download Bumblebee. I've already got my account there. Log in. This is a free site, so you do have to log into it, though, even to get the free stuff. All right, so we got us a zip file over here. So, no. So here's all of it in a lot of pieces. So they're all labeled in what different color you need to print these things, but let's just pick some of the yellow ones. So I think I'm going to need to extract this first because downloads, okay, that's fine. All right, so we're going to extract that so that we can actually open up individual files. So here I've got a folder. I'm going to go to a folder. I'm going to go to downloads. Going to find, there he is. Oh, I only extracted one thing. All right, so that was why it's so fast. So I only clicked on one thing to extract. But here's one file. It's his head. So I can drag it over here. And there is kind of a little preview of Bumblebee's head. Now, one thing about these particular files, they're generally set up in a way to where you don't have to try and figure out, well, which way should I print it? Should I print it standing up or on the back or upside down? You know, you shouldn't, I don't have to really try and figure out which way I can print it. But sometimes you do. Sometimes you have to try and figure out what the best orientation for printing. We'll talk about, you know, the things to think about when you're printing different parts, but for now, let's just assume this is how we want to print it. The main things that you want to do on your first prints, when you're still trying to figure out, you know, do you want to print this a certain way or not, is the layer height. So let's make sure you can see that it's not covered up. Yeah, it's visible. So the layer height right here. So 0.2 millimeters. That sounds really thin, and it is. It's pretty thin. You know, 0.2 of a millimeter. It's pretty thin. But that's that's a pretty conservative layer height. You can definitely go thinner with your printer. You can go thicker with your printer. The main thing that's going to happen is that the thinner ones will give you more detail because you have more layers. The thicker ones will be faster. So if you want to have more detail, particularly on this is kind of small, right? So particularly on this, I probably want 0.2 or less. The other things that you might want to deal with are this number right here. Sometimes this is in Cura, this is called wall line count, but in other slicers it's called perimeter. This is how many times around each layer is it going to print a solid wall. So 3 is kind of high. That's for a stronger part. This doesn't really need to do anything. So I'm going to go down to 2. So I've just changed it to 2. Top and bottom layers. This is how many solid layers are you going to have on the bottom of your print and on the top of your print. The inside of your print is going to be kind of hollow. So 4 top and 4 bottom is probably a bit much for this little piece. I'm going to drop it down to 3 on both of these just to kind of speed it up a little bit. This infill density, that is how solid is it on the inside. 20% is fine. Unless you want a heavy part or a really strong part, you don't really need to go above 20%. In fact, I'd probably want to go just more walls instead of just making this higher if I wanted a stronger part. Print temperature. This one says 240 because over here in the middle, it says I am printing with generic PETG. That's a different material. It's a good material, but we want to switch over to PLA. We're going to keep those changes. Now mine, that particular printer that this is working on, has a 0.6 millimeter nozzle. That's the hole in that little brass nozzle is 0.6 millimeters. Yours is probably 0.4 millimeters. So you would want to change that to a 0.4 millimeter nozzle. So we'll keep those changes again. I have to remember to change this back for this printer, but hopefully I'll not forget. So now when I switched over to PLA, these temperatures changed to match PLA temperatures. PLA generally prints around 200 degrees Celsius with the build surface around 50. I'm going to leave everything else the same for now. And then you hit the slice button and it'll go through, and you always want to preview what it did. So I'm going to click preview, and now you can kind of see those are the layers. And if I use this scroll bar over here, I can kind of drill down. You can kind of see how it's hollow on the inside. If I get over the top of it, you can see there's the 2 walls, and then there are a few things inside, but mostly hollow. And that's what I would get for my print. It says it's only going to take 14 minutes. So if I wanted to, like, well, maybe I want more detail. This is his head, so I want more detail on that. So maybe I go to 0.15. I slice it up. Going to take 18 minutes, so a little bit longer, but I have a few more layers in here. Maybe I go to 0.1. Now this printer is not set up to go down to 0.1, but just to show you the differences. Now you can start to see those layers get thinner and thinner. And again, this is probably in real size. This is something like, I don't know, maybe like that. So you can't even see the layers at that scale. But you can start to see how you get more and more detail available as your layers get thinner. If I go to the 0.3, 10 minutes, but the layers are really blocky. They're starting to get kind of blocky then. So I would recommend for most things that you're starting out with, 0.2 is a good balance of I get some detail and it doesn't take forever. 2 walls is probably good unless you're trying to make a functional part. And make sure you're printing at the right temperature for your filament, around 200 for PLA. And then infill 20% is fine for, unless again it's a functional part. And then you'll be able to print this thing out in 14 minutes and have a pretty decent head. You know, you can kind of see how it's approximating. There's the 3D model, and there's the approximation layer by layer. I am going to change this back to 0.6 before I forget and try to print on that printer with the wrong nozzle size. So I'm going to change that back. Okay, let me check chat. I don't even know where the chat went. So all right, so nothing over there. If you have a question, I'm going to shut down pretty soon here, but if you have something, put it in the chat. There is a little bit of a delay between the chat and when I see it and when it gets relayed back to you, so there probably won't be an instant response to it. Next time, I plan to have the printer built, and we'll actually interact directly with it, print some parts, do some tunings. Let's check in Canvas what I have scheduled there. So the idea that I have is, let's see. The retraction settings. So these first few, I don't know if you went and watched some of these videos beforehand or not. I didn't live stream class 1 or class 2, but they do have videos that already exist for those. But we're going to look at retraction settings. That's one of the ones that that retraction settings are one of the ones that need the most often tuning. I did see a chat, when's the next live stream? So I plan to stream Monday, Wednesday, Friday at 9:30 a.m. and go for about, you know, regular class time, 9:30 to 10:45 or so, something like that. And so the next one should be Wednesday, the 12th, at 9:30 a.m. Now there might be some times when I have to change the live stream or maybe sub in one of the existing videos, but that's the general plan: Monday, Wednesday, Friday, 9:30 to 10:45 for the streams. Let's see. And again, I will keep the streams posted, so you don't have to watch them live if you can't for whatever reason. You can watch them later on if you want to. You just won't be able to ask any questions or vote on the poll. Looks like 5 people voted. And so we've got some prints out there, some still waiting on the prints, and some that are halfway to printing. Also, when you do print stuff, post it in the Discord, you know, just so we can see it. Definitely turn it in as your assignments, assuming it was an assignment, so that we can go ahead and get some of those out there. You can actually view other people's prints that they've turned in and give feedback, get ideas from other people. And it should be a fun class. It really is up to you to kind of keep track of things and make sure that you're not getting too far behind. If you do have a failure on your printer, something goes wrong and you can't figure it out, ask in the Discord. There's actually many years of people in the Discord, and so some people that aren't even in the class will still try and help you out. And if you can't get it figured out, then we can do a Zoom or something like that to kind of look at it in person and try and figure it out. I am on campus some during the summer, not very often, but some. So usually it's Zoom kind of helping out to get the problems fixed on the potential, a jam or something like that might be going wrong on your printer. All right. I will see y'all Wednesday, and maybe in the Discord and maybe in the Canvas. Maybe I'll check out. It looks like some people have turned in a couple of these things already.